This is the last video for this section, and it's factoring by grouping. You need to practice these factoring by grouping problems until you can get them right, just like all other math. But don't get intimidated by them. It's just factoring out the greatest common factor. It's just you do it 3 times. So you want to make sure that you've got the 4.5a down really well before you go to 4.5b, because each problem you'll have to factor 3 times and factor out a greatest common factor 3 times, and that if you can't get all 3 of them right, you won't get the answer right. They're usually fairly simple though, meaning they're not like, huge numbers like 286 or something. If you have 4, 6, or 8 terms, so 4, 6, 8, etc., so even number of terms 4 or larger, then the expression might be factorable, using the method of factoring by grouping. The thing about the polynomials that you need to know is that most of them can't be factored. So in a course like this, we give you mostly ones that can be factored. Every once in a while, you'll have something that can't be factored. But we have these certain methods. And so if there's something that can be factored by grouping, it's often just set up so that it works. And the way you tell, it's a dead giveaway. You'll have 4 terms. It'll say factor completely, and it'll have 4 terms. And that almost always means you're going to be factoring by grouping. If it had 6, it would also mean probably that you're going to be factoring by grouping. But I don't think that this textbook uses that ever. They just do 4. Okay? And it's the only method that we have for factoring in this course, for factoring something with 4 terms. Okay, so it's really important to know what method of factoring do I use for this problem. Because if you're taking a test, it's not going to necessarily tell you factor by grouping. It's just going to say factor completely. So here's an example. Notice there's 4 terms. 7x minus 3y plus xy minus 21. That's 4 terms, right? 1, 2, 3, 4. So I'm probably going to do it by grouping. Now, the idea of grouping is you think of 2 of these and you look for a common factor between 2 of them and factor out the common factor instead of looking for a common factor for all 4. I would first look for a common factor of all 4 because you always want to factor out a common factor if there is one for all of the terms. You always do that first. But you'll notice there isn't. This is 7 times x, obviously. This is a 3 times a y. This is a x times a y. And this is either a 1 times 21 or a 3 times 7. Right? So there's none in common. So what we would do is we would look at these 2 and say, okay, do those 2 have any factor in common other than 1 or minus 1? Those don't count. And you say, well, there's 7, no 7 here, 3 here, no 3 here, x, no x here, y, no y. No, there's nothing in common for these 2. So you say, oh, I can't do this factoring by grouping then. Well, sometimes these things just have to be put in a different order. So what I would suggest, if this doesn't work, there's no common factor here, just take the middle 2 terms and switch them. Make sure that the minus stays with the 3 though. Remember, subtracting 3y is the same thing as adding a negative 3y. So this is actually a negative 3y. So that negative has to go with the 3 if you switch these 2. Okay? And if you switch them, you'll see you have a common factor. So that's what I'm going to do. Okay? I'm just pointing out what I was saying. No common factor for all the terms. And so you pair them up. But when you pair them up, there's no common factor for either one, actually. So if that happens, now sometimes there will be and you just go on your merry way. But sometimes this happens where there's no common factors, and so you can't do anything, so you switch the two middle terms, and this will always work. Because we just won't give you ones that won't work. Okay, so I switched them, and notice that I had minus y over here, minus 3y. I still have minus 3y. So the minus went with the 3y. So this is still plus xy. See, I just wrote them in a different order. Now you group them like this, and you see, aha. These two have a common factor of x, so I can factor out the x. These two have a common factor of minus 3. They're both negative, so I would factor, when they're both negative, I would factor out the negative as well. It just makes it come out easier. So they have a common factor of the 3, and you can take the negative out as well. So factor out a negative 3 here. So there's two different factorings so far, and then you'll see where the third one comes in out next. So the greatest common factor of the first two is x. Greatest common factor of the second two, I would use negative 3, since they're both minus. So the rule, there is actually a rule here if you want to get these right. If this third term, if it's negative, regardless of whether the last term is negative, if this third term is negative, always factor out a negative number for take your GCF. It's not really technically the greatest common factor. That would be 3, because 3 is bigger than negative 3. But think of it as the greatest common factor. It's the thing you're going to factor out as negative 3 regardless. So this is kind of not quite right. It's actually not the greatest common factor. But I'm going to factor out the minus 3 anyway. Okay, the greatest common factor is 3. And so when I do that, I get this. So I write down my common factor, my greatest common factor for the first two. And I would actually write these lines underneath them. Some people put parentheses around them. You know, you're grouping. But that will mess you up, because where do you put the parenthesis here? In front of the negative? But then that would mean you're multiplying. You put it behind the negative, then you'll get it wrong because you're applying the negative here. So take my word for it. If you put parentheses around here and there's a minus here, you're probably going to get the second two wrong. You're going to get these wrong. Probably have a minus 7 there. So I just put a little bracket underneath them. That way, if there's a minus sign in there, it doesn't mess things up. Okay? So let's see. These first two, I've got the common factor of x. So I'm going to write down x, parentheses. Then I'm going to have two terms inside. So these two terms, and the two terms are going to be this one over x, which gives you 7, because the x's cancel, right? And this one over x, the x's cancel, you get y. And then here, you'll see why I'm doing dividing here, because when you do the negatives, it's confusing if you think of taking out the factor. So, well, it depends. If this was a plus, it'd be more confusing. Okay, so I'm going to factor out the minus 3. So this over negative 3 is y. And negative 21 over negative 3. Negative over negative is positive. I write down the plus, and 21 over 3 is 7. Now, notice I went from having 4 terms, 1, 2, 3, 4. Now I only have 2 terms. 1 term and 2 terms, the second term, right? So I went from 4 terms to 2 terms, and now I need to go from 2 terms to 1 term. That'll be factored. And notice this term and this term have a common factor of y plus 7. This one's just written backwards, but it's still y plus 7. So I can factor out the y plus 7. And you can put that down here on the left, or you can put it on the right and put these numbers on the left. I usually keep this on the right since it's on the right of the 3, it's on the right of the x. Right? So when you factor So I just rewrote it so that I just switched the 7 plus y to y plus 7 just to make it more obvious that these two are the same factor. So the common factor here is y plus 7. That whole thing in parentheses, y plus 7 is a common factor. Okay. So factor it out. So you get this. Now, how did I get that? Well, if you can think of it, okay, here's this term, and I took out the y plus 7. You need the parentheses, right? And I'm left over with an x. So the leftovers are going in these parentheses. And I have an x minus 3. X minus 3. Or you can write down this y plus 7. Take each of these and divide them by y plus 7. If you take this first one over y plus 7, the y plus 7s cancel. This over y plus 7. And you get x. And then the second one over y plus 7, the y plus 7 cancels, you get minus 3. But you have to put these two in parentheses or it'll be wrong. Now, check your answer by multiplying this out. You can do this on paper, okay? Or you can just do it in your head. Look, I'm going to compare it with the original. X times y. Well, there's the x times y, right? X times 7. Well, that's 7x. There it is right there. Minus 3 times y is minus 3y. Right there. Minus 3 times 7 is minus 21. Right there. So you can always tell if it's right or not. If it's not right, go back and figure out the mistake. Usually the mistake is you made a problem with a sign, or you don't understand what's going on at all. So they have some examples like this in your reading as well. And then, of course, remember when you do homework problems, if you don't know how to do a problem, you can click on the, I think it says tutor. There's a button. If you're in the practice, not in the certified, but if you're in the practice, you can press on a button. I think it says tutor. And then you can have it tell you the answer, or you can have it go step by step with you through the problem. So it's just like having another example. And you can see exactly where you went wrong and learn from your mistakes that way. It's really nice. Okay, that's it for that section. I hope that your homework goes well on this. It's very important stuff.